A Nazi cryptography machine based on clockwork routers, it was used to send and decipher encrypted messages written by the Axis military forces, being one of the most important engineering feats of recorded times. This machine still is a subject of many conversations and debate even in today's world full of complex digital encryption protocols. This machine remains one of the most complex encryption protocols to the date. This is an enigma. As impressive as the machine is, a feat of equal importance is that one of the Alan Turing and the Alice Enigma team, which cracked the Axis code and made a significant advance in winning the Second World War. Many men of both sides took the fort lights, hiding the trench and bunkers, using weapons and explosives to try to best their enemies. But behind them were also soldiers who, instead of using guns, fought with their brains and what they knew about mathematics. The Enigma Machine was a topic not only of mathematical engineering, but also of history and politics and wartime strategies alike.
Cryptography is the discipline that encrypts and decrypts messages using an algorithm and that also allows the message to be returned to its original state. It's very much in hand with military campaigns and government secrets. Plus, it was very important in World War II, where this became another fighting front.
The Enigma machine was used by the German military command to encrypt strategic messages before and during World War II. In 1930, the codes were broken by the Polish under the leadership of Marin Rejewski, an important mathematician. Then, in 1939, with a high probability of a German invasion, the Polish delivered the code to the British, which created a secret code-breaking group denominated as Ultra. This was possible by the guidance of the mathematician and logician Alan Turing.
The machine was built up by 3 cylinders originally. The cylinders were an elemental part of the system. Each 26 pulsations on the alphabet, the machine changed to the next cylinder and further. Adding another cylinder, the fourth one, made the machine almost impossible to decipher, having a lot of possible alphabet combinations. The basic 3-router Enigma has 26 times 26 times 26 equals to 17,576 possible router states for each of 6 real orders, giving 6 times 17,576 equals to 105,456 machine states. For each of these, the blackboard with 10 pairs of letters connected can be in 150 trillion 738,274,937,250 possible states.
Germany, during World War II, had a huge advantage over other countries because the Enigma code they used was practically indecipherable. This since a fourth cylinder was served to make it more difficult to decrypt the message. Furthermore, the German army changed the code to be used every day, so the Allies had only one day to decipher the message because the next day the code was changed again.
The context for the machine is simple. After the humiliating defeat we suffered after the First World War, I decided to make use of the technological advances of the time to try and improve the communication protocol the German military used so that we could be dominant in the conflict.
making use of the many cryptography materials that the Polish intelligence service recovered. I could create the internal writing of the machine, the part responsible for generating the permutation necessary to script message. This wonderful electromagnetical machine worked by employing in a keyboard with all letters of the alphabet, similar to the typewriter. These keys were some kind of switches that enable the electrical devices and move rotors, which in turn could encrypt entire message.
Cracking the Enigma code improved the conditions for the allies and helped reduce the time the war went on. This happened due to my machine, called the Turing machine, which allowed me to decipher Enigma message easily. At the moment when Germany invaded Poland, I was working for the Government Code and Cipher School in the British Intelligence Service. It helped me to get experience and also tools that allowed me to create the machine that later on deciphered the Enigma code.
I acted as the director of MI6 and Operation Ultra, which was the largest cryptography operation in the entire world. In this operation, we gathered mathematicians and cryptographers and were recruited to obtain results in deciphering codes by the Nazis. During the Second World War, I seized and deciphered codes, which meant we obtained a lot of power and information through this operation. After the war, I was in charge of preparing military codes in the Cold War against the Soviets.
Enigma is a very complex machine that even today remains one of the most advanced cryptographic devices. It is one of the few machines made in the 1900s that could still be effective against modern technologies and systems, since its options to decode can easily go over the number of atoms in the universe. One of Turing's demonstrations of intelligence was in 1950, as he sidestepped the traditional debate concerning the definition of intelligence, introducing a practical test for computer intelligence that is known simply as the Turing test. The Turing test involves three participants: a computer, a human interrogator, and a human foil. The interrogator attempts to determine by asking questions of the other two participants, which is the computer. All communication is via keyboard and display screen. The interrogator may ask questions as penetrating and wide-ranging as he or she likes, and the computer is permitted to do everything possible to force a wrong identification.
Task with solving the Enigma machine. This one is composed of four parts: the keyboard, the connection panel, the rotors, and the bull panel. It has an electromagnetic rotor mechanism that has the letter of the alphabets. The system of the Enigma machine is built around three rotors, which are the ones that help find the encrypted message. To encrypt the message, you begin typing the first letter of the word you want to write. This will then send an electric pulse to the connection panel, which verifies if the letter you type is connected to another one. Afterward, the impulse is sent to the rotors, which move like a clockwork, in which every time a letter moves, the first rotor moves as well. When it finishes one revolution, the second one follows, and then the third one does. These rotors have 5 different interchangeable configurations for the 3 slots that have different letter orders but all have the same amount of options. When the impulse has successfully been transferred across the rotors, it goes through the same process backwards, and finally it is sent to the boot panel, which lights up a boot corresponding to the already encrypted letter.
The formula used to determine how many total encryption options this has is a very complex one, thus we will explain it step by step. First, there's the connection panel, which is the most mathematically complex part. This panel has all the letters in the alphabet, one of each letter. This means that there can only be a maximum of 13 cables, as each cable connects 2 letters. Thus, we have to consider that these letters can be repeated and that they won't have any specific order. As such, we use the formula 26C2P, where P is the number of cables used. Then, in the rotors again, we have 26 letters. For each rotor, if we assume that we have the general purpose rotor model, then it would leave us with 5 different possible disks for the 3 rotors. So that would be 5 times 4 times 3. But there was also all the different possible initial positions for the rotors, which would give us 26 times 26 times 26, or 26 to the third power. So the final formula, if we used all the 13 cables and had the general purpose rotor disks, would be 26C26 times 26 to the third power times 5 times 4 times 3, which would give us a total of 8 times 10 to the 108th power. The formula of combination is used in order to determine how many ways the P cables can be connected with the 2 ends of each selected socket. The pattern consists of the first cable inserting the first end of the first cable into any of those 2 P sockets, and the second end with the first cable. This has a total of 2P minus 1, which means it has a total of 3 sockets to choose, which are available. Then insert the end of the second cable, and this will have 2 minus 3, 2P. Then insert the first end of the second cable, and this will have 2P minus 3 free sockets to choose. This pattern continues up to the last cable. Therefore, the number of different connections which could have been made by an Enigma cipher machine is 26CP. Therefore, the number of different connections which could have been made by an Enigma cipher machine is 26C2P times 2P minus 1 factorial factorial, or more simplified, 26 factorial over 26 minus 2P factorial times P factorial times 2P. It is also important to understand that the maximum number of combinations does not occur at 13, but happens at 11. During war, as an important fact, Germans never changed something known as the disk. They created different groups of special purpose machines. This made possible to place the leftmost position, the left. They created different groups for special purpose machines. This made possible to place the leftmost position rotor for the cryptographer to select any of the 26 disks. The total number of ways of possible combinations or ordering Enigma machine is 26 factorial times 26 factorial minus 1 times 26 factorial minus 2. The total possible combinations, considering what was last said, would be 3 times 10 to the 114th power. Now consider the Enigma that the Navy used would have had. Now consider the Enigma that the Navy used, which had up to 8 rotors with a ton of different rotor disks. The option of guessing surpassed the number of atoms in the observable universe by a landslide.
Turing cracked the Enigma machine code by creating the British bomb. It was an electromechanical machine composed of the equivalent of 36 different Enigma machines, each containing the exact wiring of the German counterpart. When the bomb was switched on, each of the Enigmas allocated a pair of letters from the obtained crypt text. For example, when D becomes D in the guessed word, the thing with Enigma is that even with the machine Turing built, it still was too much for the machine to do alone, so they gave it some help with some words they knew were in the message, such as Heil Hitler, the Nazi chant the Germans said to glorify the monster of the 20th century.
Truly, the Enigma Machine was a wonder in every possible aspect, be it an attempt to win war by the Axis or attempt to counterattack by the Allies. The extensive logic of the Enigma Machine was not to underestimate. Nowadays, 250 machines still exist and are kept at museums and conservatories to commemorate the work and single pair of these machines could achieve. The world doesn't need any more wars, but the Enigma Machine is a perfect example and inspiration for what a current-day military encryption protocol could look like. Encryption nowadays is a priority, as governments try to keep state secrets and citizens demand privacy and security. If the German and British governments could create Enigma back then, having used a massive machine to make it, the possibilities of making a compact and ultra-secure encryption protocol today are great.